Hello everyone. Today we begin with a new chapter, atoms and molecules. Everything around us, pen, book, even the air, is made up of something so small we can't even see. Let's find out what the smallest building blocks are. Introduction, overview, overview of what this chapter covers. First is laws of chemical combination, Dalton's atomic theory, concept of atoms, molecules, and ions, chemical formulae, and mole concept, and basic numerical problems. Okay, so let's start with law of conservation of mass. This law is proposed by Anthony Lavoisier. This law states that mass is neither created nor destroyed in a chemical reaction. For example, hydrogen reacts with oxygen gives water molecules. Means H2 plus O2 gives H2O. Here, total mass before is equal to total mass after. Law of constant proportion. Law of constant proportion proposed by Joseph Proust. This law states that a compound always contains the same elements in a fixed mass ratio. For example, water. For example, um, in the water, H2O, that is hydrogen is to oxygen. Here, 2 is to 16 means atomic mass of hydrogen is 1, and there in the water molecule there are two hydrogens, so this 2, and atomic mass of oxygen is 16. That's why here 2 is to 16. Okay, and the ratio is 1 is to 8. Okay, it is applicable to all pure chemical compound. Next is Dalton atomic theory. Dalton atomic theory was proposed by John Dalton in 1808. And here are the main postulates of Dalton atomic theory. Matter is made up of indivisible atoms. Atoms of an elements are identical. Atoms of different elements differ. Atoms combine in a fixed whole number ratios. Atoms are neither created nor destroyed. Next, atoms and molecules. Atoms. Atom is a basic unit of elements. That means atom is the smallest unit of element. And the molecules are a group of two or more atoms bonded together. Types of molecule. First is monoatomic. For example, helium, neon. Diatomic, O2 means oxygen, nitrogen, O2, N2. Triatomic, O3, ozone. And the polyatomic molecules are P4 and S8. That means phosphorus and sulfur. Atomic symbols. It is represent elements with one or two letters based on English or Latin names. For example, hydrogen, H for hydrogen. And Na means sodium. From Na is a Latin word that is from Latin natrium, and natrium means sodium. So symbol of sodium is Na. Um, for symbols, first letter is always capital and second letter is lowercase, if any. Next is atomic mass. Mass of a single atom measured in unified atomic mass unit, that is U. And the standard atomic mass of carbon is 12. That means 1 U is equal to 1/12 mass of 1 carbon. This C12 atom. For example, H is equal to 1 U means atomic mass of hydrogen is 1. So H is equal to 1 U. U means its unit. Okay, atomic mass unit. And atomic mass of oxygen is 16. So O is equal to 16 U. Okay, and atomic mass of carbon is 12. So C is equal to 12U. Molecules of elements, some types of atoms, uh, for example, H2, O2, N2, Cl2, etc. Diatomic molecules are common in gas. Molecules of compound, there are different types. There are different types of atoms. Um, First of all, what is compound? When the different types of atoms when combined to form compounds. Okay, means there are different types of atoms are attached. Means there are different types of atoms are bonded together to form compounds. For example, water molecule H2O. H2O means H2O is made up from two molecules of hydrogen and one molecule of oxygen, and another is CO2. CO2 is also a compound that is made up from one molecule of carbon and two molecule of oxygen. Okay, it is the smallest part of compound that retains proper. Okay, next is ions. Ions. Ions is a charged particle formed by gain or loss of electrons. First is cations. Cation is a positively charged species. For example, Na plus, Ca2 plus, means sodium plus and calcium 2 plus. Okay, and anion. Anions are negatively charged species. For example, Cl minus, that is chloride ion, and O2 minus. Okay, they are formed during ionic bonding. Next is chemical formulae. Shows types and number of atoms in a molecule. Uses atomic symbol, valency of valence atoms. Example, H2O. H2O for water molecule, and CO2 is a carbon dioxide, and H2SO4. H2SO4 is a sulfuric acid. Okay, and the rule for the chemical formula is a crisscross valencies. And next is molecular mass. So, molecular mass is the sum of atomic masses in a molecule. For example, at a molecular mass of H2O, molecular mass of water molecule means H2O. Here there are two hydrogen atoms, and the atomic mass of hydrogen is 1, so 2 into 1 plus atomic mass of oxygen is 16. So into 2 into 1 is 2, and 2 plus 16 is 18. So the molecular mass of H2O is 18U. Next is formula unit mass. Formula unit mass is for ionic compounds. For example, NaCl. NaCl. Here, atomic mass of sodium is 23, and the atomic mass of chlorine is 35.5. So the means the formula unit mass for NaCl is 58.5 U. That means here 23 plus 35.5 is equal to 58.5 U. Next is mole concept. 1 mole is equal to 6.022 into 10 raised to the power 23 particles. That is Avogadro's number. Mole concept is used to count atoms, molecules, and ions. 1 mole of a substance is equal to its molecular mass in gram. Next is mole relationships. Um, Relationship between mass and moles. Moles is equal to mass by molar mass. And the relationship between moles and number of particles. So the number of particle is equal to moles into Avogadro's number. That is 6.022 into 10 raised to the power 23. Next is a volume of gas at STP is equal to 1 mole is equal to 22.4 liter. Next is numerical examples. For example, convert 36 gram of water to moles. Given H2O is equal to 18 U, so 36 gram is equal to 2 moles. Find the number of particles in 2 moles of CO2 is equal to 2 into here we have to find 2 moles. So here we take 2. Okay, and multiply by Avogadro's number. Okay, so 2 into 6.022 into 10 raised to the power 23. So our answer is 1.2044 into 10 raised to the power 24 molecules. So the number of particles present in 2 moles of CO2 is 1.2044 into 10 raised to the power 24 molecules. And the summary here is quick recap. Uh, in the PPT, we have seen laws of chemical combination, Dalton's theory, atoms, molecules, ions, and formulae, and mole and calculations. Thank you.